the topic. Okay, I'm Mario Kušek. I'm from University of Zagreb, from FAIR. And this is experience from, actually, we had Horizon project, which lasts for 3 years. It just finished by the end of last year. And those are the experiences that we were doing middleware for the IoT system. And we did that with microservices. So our experiences in using microservices in such environment is what I'm going to talk about. So a little bit about me. I start, since this is Java conference, I started using Java in '95. It was an article in a local magazine, Bug, about new programming language. And I installed it. I believe it was alpha version. And try to put some code in web pages, and it was there. There was also a Java browser that could run Java code in web pages, so that was cool. And then I said, okay, for my diploma thesis, I want to do something in this language. So this is something. And I hooked up, and after I finished my diploma thesis in '97, I started working at the university. On some projects with Ericsson, Nikola Tesla then, and start teaching Java as well. In the first course that I was teaching was concurrent programming, and my professor told me, okay, you can teach concurrency in Java because it was built in. It was one of the first languages that is now popular that has some concept built in language. And from then on, I still teach Java. Now this year we started in the first year of our undergraduate study. We have more than 600 students. And that is Java background. And I'm also doing IoT, Internet of Things, and that started in 2011 with also some project, and we have IoT laboratory in our department as well. So I don't know how much do you know about Internet of Things. Do somebody do something with the Internet of Things? Yeah, few people. Okay. So for the rest of you, what is a thing? Thing is actually physical object that we put together with some electronics and put some communication and connect it to the internet. That is the basic what it is. So in order to do something with that, you need to have connectivity, you need to have ID of that device, so you need to connect to that. And you can send comments or get the data from such things. Things usually are either sensors that are reading something from the environment and sending data to some other part. Or you can send commands like actuation, for instance, turning on, off lights and different things. Or combination of both. So in order to connect those devices to the internet, actually if you have, for instance, smart home environment, so you have probably a router that you connect to the internet, and your device has local IP address. So how to connect from mobile phone? I don't know. I want from here to turn on heating in my home. So how can I connect? I need to have some kind of things in between, because my home is connected to the internet but doesn't have DNS entry and so on. So what actually is done is that you usually have platform that is actually doing a lot of things for you. And your mobile app actually connects to the platform. And then the platform, your devices from the home connect to the platform, start connection from the home to the platform. And then through those channels, you get actuation messages to the devices. Currently, in the world, there are more than 400 platforms. So it's a huge number. And most of those platforms are specialized in one area. For instance, I don't know, from some kind of smart mobility, or I don't know, maybe smart home. Some platforms are for the electricity, for the power line companies and so on. So there are different platforms. And as I said, how it is connected, so you have devices in the home, connects through some kind of gateway to the platform that is usually in the cloud. And then you can also have some devices, some things that could be directly connected to the platform. For instance, if you have on the thing mobile network, so you can connect directly. You don't need a gateway in between. And when you are using that, you use some kind of IoT application that is connected to the IoT platform. And that's fine. So what are the problems here? So the problem is the following. Since we have lots of platforms, and they are different, they have different data structures, they have different measurement units for what it is reading from the sensor, or they are specialized in some vertical domain and you cannot connect to them. For instance, you have a company that is providing your security in your home with alarms, and they have their own application. So you can use to turn off, on alarm and so on. But then you have your heating system that is provided by other companies, and those two things are not connected. Then you buy some, I don't know, Philips Hue or IKEA lights that you want to control through mobile phone, and this is the third platform, or the third way to do it. So you will have a bunch of applications specialized in different things, and that is not good. So the idea of the project was to create some middleware that you can connect those platforms, easily connect those platforms in that middleware, and then to provide the application developers opportunity to easily create applications that are cross-domain. So not just heating, not just security, not just small things in smart home or in the city, in the smart city, you can have different things and so on. So that was the idea. And the project was called Symbiosis of Smart Objects Across IoT Environments. Short name is symbIoTe. And it lasted for 3 years. It was, as I said, funded by European Union funds. And there was 15 partners involved in the project. Some universities, institutes, and most of them were SMEs. And we developed something. So we have 15 partners. We had around 25 developers that were not developers full-time on the job. And that is the problem, how to build that. So first we created requirements. We had the meetings. Every 3 months we had the meetings. We had 4 meetings per year. And to decide what to do. So how we're going to do this ecosystem. So the first layer of the idea was how to do it. We'll create core services, and then we will, different IoT platforms will have small adapters that we will build inside the project. And those adapters will be connected to the core services that then they can register what they have on their IoT platform, what kind of devices, what kind of things. And then we will also provide the adapters as a library for the application developers to use the core services and those IoT platforms. So that was like a marketplace for different type of IoT devices. The second layer is, okay, what if some IoT platform doesn't want to expose everything to everybody? Because this was like a public thing. So like you have Google for searching web, you will have those services for searching IoT devices, what you can do. So the second approach was also, but we formed like layers. So this was first layer of compatibility. The second one was, okay, those IoT platforms can form federation and exchange data in between. The third layer was, okay, what if we have smart space like this place? If I have application that I'm using home, I would like to use here as well, for instance, to read the temperature in the room, or to propose the changing of the temperature, or to reduce light, or I don't know, if I'm going to the toilet, I want to turn it on without touching anything there, and so on. So the idea is to have some kind of smart space to discover the things that are around, and then you can use that as well. And the last one was actually roaming of devices between those smart spaces. So if you have, I don't know, a smartwatch that is measuring something on you, and you go to gym or to a doctor, why don't the gym, the monitor there that you are working on some equipment show you the, I don't know, heart rate or something like that, or when you are going to the doctor to see, the doctor can see automatically your heart rate or some other parameters. So this was the idea. So after defining what we're going to do, we start to gather requirements and decide how to develop that. So we said, okay, we would like to have some kind of agile process, but agile process with 15 companies, it's quite hard. So let's say, okay, it will not be so much agile. It will be like agile-like, so we will try to use some things from there that are applicable in such an environment. So what we actually, the idea was, okay, we will have iterations of a software, okay, that's fine. Then we will have 4-week releases. That never happened. We had 3 months releases. Because we were not dedicated, all of us were not dedicated only to that project. So that was the plan. We said, okay, we will have, instead of daily meetings, we cannot have daily meetings, because, as I said, we were not involved all the time. We will have a weekly meeting with all developers with video conference, and we did that. So that was our core of our communication. Beside that, we also use Slack, emails, and everything else. And we planned 1 to 2 weeks internal component releases, and that was also not happening. So we had only 3 months releases, so roughly around 3 months. We decided to program in Java, and we decided that we will use testing, unit testing, with code coverage more than 70%. Most of this, so all the components are in Java, and most of those things have code coverage more than 70%, but some don't, because some partners didn't do their work. Unfortunately, we couldn't force them to do it. And for tools, we use Jira, GitHub. This is open source, so everything is on GitHub. GitHub for versioning, and Travis for CI. But this Travis for CI was just for each component, each service, not the whole system. As you saw the previous talk about deploying everything together, we couldn't do. Some are quite reasonable things why we couldn't do. I will tell you a little bit later, but some were not. So what was the high-level architecture? So this is the core services, and we defined interfaces, and then we have this cloud domain, cloud services. We define interfaces in there, and those are for different layers. But we will now, I will concentrate only on 2 of those. So when we define the architecture, we define which are the components in there, what are their responsibilities, what are their interfaces, so what are functionality that we want to do. We decided that this is the core and this is the cloud part. We decided that in between we will have HTTP communication, because core can be in one place on the internet and the cloud part is where the IoT platform is deployed. And and the application were also using HTTP. We also consider security from the beginning, and the security was actually delivered in the system through some components, which actually we have HTTPS communication all the way, and we have also attribute-based access control for everything. Okay, so after design, we had a meeting, and then the partner that has most of the PMs for the development, the majority of them, not in relative to the others, and they proposed that we will use microservices because this is most natural way to divide the job, what need to be done. Then we consider different drawbacks and positive things as well, and say, okay, yeah. And then we divided. One microservice was mostly implemented by one organization. So we will have small teams inside organizations. And it will have one repository. That's fine. But, and we will have also a component owner from that organization, so the person responsible for that component. But what happened afterwards is that we divided those components according to functionalities that we designed, not by the functionalities to the end user that is using. And then we got with tightly coupled system. And we had more problems than doing everything monolithically. Actually, that is one of the outcome of the project. So we learned that we need to divide it better. For the frameworks, as we are using Java, we decided to use Spring Boot, and Spring Cloud components. And we hope that we will have problems with scalability. So probably some components will be delivered in more than one instance. So we said, okay, much easier is to do scalability with RabbitMQ messaging communication between those components. And yeah, that's true, but then we had some other problems that you will see as well. So in Spring Cloud, we use Spring Cloud config for configuration in Git repository. We used Zipkin for distributed tracing. Spring Cloud Gateway then was not part of Spring Cloud. It was not even in the beginning. So what we use Nginx as a gateway. And from Spring Cloud Netflix, we use Eureka for service registration, Ribbon and Feint for the clients as well. So what are the problems? First, microservices that we used were not divided by domains, but by functionality. So this was the problem, that we change something in one component, then we need to change another one and so on. So we need to communicate how to do that. And we could not easily deploy each component differently. So different time frames and everything. So that was the first problem. So since this was research project, the research and innovation project, we have lots of things happening in how the messaging was done. So we had frequent changing in messaging. And the problem was hard to integrate that. Integration testing, that the whole system is working. It was not a problem for one microservice, but the whole system needs to work all together. So we had problems with them. And we also had communication between teams, problems with that. So we need to discuss everything. So not just this one meeting per week, but we need to have different meetings in different parts and so on. And yeah, that was a problem. For the RabbitMQ, most of the communication was designed as request response, and RabbitMQ is messaging, so you send message and you don't expect response from that. Yeah, you have workaround how to do that, but it's not natural to messaging. So we didn't pay attention before, so when we actually started using, we saw some problems in there. Also in the RabbitMQ, we didn't do, because the changing of the messaging, we didn't version APIs. So we didn't have services that could support more than one API, more than one type of the same message from previous version and now. And yeah, we saw the Spring Cloud contract is good for defining this contract between microservices. But it came quite late for us. First, the first 1.0.0 version was in September 2016, so it was like 9 months in the project. And second thing is that documentation was mostly concentrated on the HTTP communication and not on the RabbitMQ. There are some examples, but there are not so many different things that we need in there. So we couldn't use that as well. The consequence was that we had painful integration testing. And yeah. Then we decide, okay, we see that those services actually communicate with the same data. We know that the microservice should be self-contained, not to share code with other microservice. But then we had the overhead of building the same object, the same classes, to program the same classes in different microservices. And we said, okay, but if they are the same, why don't we put them in a library and then reuse them? So we did that. So we create symbiote libraries, repository, and put there. And then we need to publish that. We decide to publish that on Jetpack. So we have immediate versioning. But then you had problems with versions. So you can say, okay, I will use the latest snapshot, and then somebody changed that, and then your program is not working. So then we decide, okay, now we will use semantic versioning for all the components, which means that you have 3 numbers. The first number, major one, is the major release when you break the backward compatibility. The second one is when you put some things into a service, but you don't break the compatibility. And the last one is for bug fixes. And we start to use that throughout the project. We had one component which is called AAM, Authentication Authorization Manager, which was designed to use for security, for checking those attribute-based access control. So every request that comes outside of the system need to ask for the AAM, is it okay or not? Do that user that sends some, we use JSON Web Tokens with the attributes. Does that user have a right to do or to read something from this resource? So this communication need to be implemented in every service, and we decide, okay, let's put the client part into a library. So we create symbiote security library, and then every service needs to include that. So we decided that symbiote libraries actually depend on this security library as well. Okay, then we had release. In the project, we had something that is called open call. We had 2 open calls that we announced to the world that we want some other parties to become part of the project, and they were paid for using the system. And they were like our early testers of what we did. So we need actually developing companies that are doing something in IoT world to use that, to see that it is easy to use. And the first thing we need to do is, okay, we need to deploy that. So the core service is not a problem, but the components for the cloud part, because each IoT platform needs to have those cloud components, cannot be deployed automatically because we don't know where it is. So it needs to be on the premises of the IoT platform owner. So they need to create some kind of automatic build. But if we develop some new service in that part, we don't want that just deployed to everybody. It's their decision they need to do. So we couldn't do automatic deployment of that part. And then for this part, okay, how can we deliver? So the first version of how to deliver is you have codes on GitHub, and then we created support web pages on GitHub Wiki with instructions to do everything. But it was complex and slow, and everybody that need to do something that is not directly explained there need to know the insides of those components, and that was not good. So it was like hard to configure. So what we did, we automated the complexity and slowness. So when we automated that into script, it was much faster. And then we also created configuration generators similar to Spring Start Spring IO. so that you can get configuration from one place and just start the scripts that is using that configuration. And that improves a lot. So the second stage was delivering from jar files that we already prepared on the Jetpack, and then running scripts, and that solved lots of problems. So this is similar to that. But the problem was the following: if something is not working, okay, it's not working, so what can I do? Go to sources and see what is going on, or contact us on Slack. And that was quite bad. But this is similar thing to the Spring Boot. If something is not working as you expected, you need to dig to the documentation or contact somebody. I don't know how to solve that, but yeah. And the scripts are bash scripts, and some of our partners had Windows servers and they cannot run it there and so on. So it was like, okay, we'll see how to support it. So in the third stage, we support it in Docker containers. So we created Docker containers for all of them. So it is easy startup with the Docker Compose and Docker Swarm. Git as a repo for configuration. But in the first version, it was inside the Docker image. So we need to pull it out and put it into volume because you cannot change, create customs. And we need to create different documentation for different Dockers, because somebody is using just Docker, somebody is using Docker machines. So we had different configuration. And we had the problems with port mapping in that, so we described that as well. And for testing for instance, if somebody would just want to test it, we need to have public IP address, DNS, and certificates in order to just run that. And that was not good, so we use ngrok as a tunneling client and explain that, and then we had configuration for that as well. And at the end, now the project stopped because it's finished, but we will also support some of our partners will also support further development and further maintenance of the code. But when we had everything in Docker, and as you can see, the memory consumption was just on the start at 1.5 gigabytes. And it is doing nothing in the beginning. Yeah, but when you start using it, it grows to 2 to 3 gigabytes of RAM. If we had that in one monolith, it will be much less. So what can we do? So for the future work, and we are pursuing that. We didn't touch that everything because we had this week review in Brussels, so we didn't want to touch anything and break it down. We are looking at Java 11 that was released in September, because we have new garbage collection, string internals, netty in Spring Boot, which is supporting that, and also application class data sharing between the virtual machines in Dockers. But we couldn't do that earlier because we didn't have support from Spring Boot for the Java 11. It was in October 2018. And then we used Spring Cloud. It was released in January this year, so just a month ago. So we are looking into that we will use probably that to shrinken the memory consumption, because I think that this is important. So in conclusion, what are some experiences? Distributed teams require lots of communication. That is much more than the local team. And it was a big team altogether, so this is a problem. Then we have to be careful choosing technologies that you are using with microservices. Does it have support? Does it have all the things? If you don't have experiences, now I will try to start with monolith and see what is wrong with monolith, and then if some parts need to be put in microservice, then just extract that part. I will not go from the beginning in the microservice way. Divide features to microservices that are independent and scalable. We didn't think about that. We just divided through functionality. So we don't have scalability. And we have burden of communication between microservices. So versioning of API is very important. And yeah, automatic building. Decide time for building, testing, automation system. Decide which persons or which teams are responsible just for that, and start from the beginning. So when you set up the automatic build, it is much faster than to set it up afterwards. So those are my conclusions. So thank you. Okay, if you have any questions, you can contact me. Any questions here now? Maybe. Okay, contact me or on Twitter or mail. And here are links for the software that we produced. Okay, thank you.